Hi, hello everybody. So today we have a rank booster from turnover number. So the question says carbon dioxide to bicarbonate ion conversion by an enzyme. So carbon dioxide is converted to bicarbonate ion by an enzyme. And the molecular weight of the enzyme is given as 30,000 grams per mole. And the turnover number is also given as 4 into 10 to the power 5 per second. The minimum number or the minimum amount of the enzyme in micrograms, important, required to convert 0.44 gram of carbon dioxide to bicarbonate in 100 seconds is. Okay, so this question is actually from turnover number. And the equation of turnover number or turnover frequency is the number of moles of, so they have given in the form of reactant. Okay. So number of moles of reactant reacted, or you can also write number of moles of the product formed. Okay. Divided by number of moles of enzyme required into time. This into time comes in the denominator. This is the turnover number. So here the reactant mass is given. Number of moles of the enzyme is something that we don't know. We have to find, and we have to substitute the value of time, which is given as 100 seconds. Turnover number is also given. Let's try it out how to do it. Okay. So first of all, the question is to find the mass of enzyme in micrograms. That is a question. Okay, so this question was actually asked in GATE. All right. So first we have to find the number of moles of the reactant. Number of moles of the reactant. Now, in the question, they have already given that 0.44 gram of carbon dioxide is converted. Now, if you know the molecular mass of carbon dioxide, so carbon is 12 and there are 2 oxygen, which is 32. So in totality, this is 44. Okay, so the number of moles of carbon dioxide which is converted is 0.44 divided by 44 grams per mole. Correct? So this will give us 0.01. This is equal to 0.01 moles. Now let's put in all the values. Turnover number is already given. It was 4 into 10 to the power 5. 4 into 10 to the power 5 per second is equal to 0.01 moles divided by number of the moles of the enzyme is something that we don't know into 100 seconds. This is what we have. Now we'll rearrange for x. This is 0.01 moles divided by 4 into 10 to the power 5 per second into 100 seconds. So this per second and second gets cancelled. Right. So what you have is 0.01 divided by 4 into 10 to the power 7. Right. This is what you have. So the value that I'm getting is number of moles of enzyme after calculation. I'm getting as 2.5 into 10 to the power minus 10 moles. Is it? Let me recalculate. 0.01 divided by 4 into 10 to the power 7, right? Yes. So it is 2.5 into 10 to the power minus 10. Now in the question, they have not asked the number of moles. Instead, they have asked the mass. So we already know to find the mass of the enzyme, it is just the number of moles, which is 2.5 into 10 to the power minus 10, into these many moles, into the molecular weight of the enzyme is given as 30,000 grams per mole. So moles and per mole gets cancelled, and let's multiply this. So what I'm getting is 7.5 into 10 to the power minus 6. This much of grams. But in the question, they have asked to convert it into micrograms. We know that 1 gram is equal to 10 to the power, 1 microgram is equal to 10 to the power minus 6 grams. So you have 10 to the power minus 6 grams over here. So this is simply 7.5 micrograms. So the final answer that you have to enter is 7.5. In the question, they had asked us to round it off to just 1 decimal point, and we have got it. 7.5 is the right answer. In the answer key also, they had given 7. Okay? All right. Thank you.